Hi, welcome to our first video in the section on stoichiometry. I'm glad you're able to join us today, and we're going to go through what stoichiometry is. It's really not that bad. It sounds kind of menacing, but it's not bad at all, especially the way that we've learned to teach it over the last few years. And then from stoichiometry, we'll go into percent yield, and we'll be done with the unit. And then the next unit is on gas stoichiometry, which is relatively easy as well. So here we go. First of all, we're going to talk about mole to mole ratios. And we talked in chapter 10 about what a mole was. We talked about how if we look at the periodic table that we can determine, for example, if we wanted to measure out a mole of aluminum, we'd measure out 27 grams of aluminum. So that's essentially what a mole is. It's 6.20 times 10 to the 23rd of anything. We typically use it for very small things like molecules or atoms. And it allows us to, with this mole to mole ratios, it allows us to convert from one item to the next. So if we know how many reactants we start out with, it's able to tell us how many products we're going to form. Stoich is the root word means element, and metry means to measure. And so that's where they come up with the term stoichiometry. We typically will just call it stoich. Chemical reactions proceed as long as we have reactants to make them happen. And our reactions are going to stop when one of those reactants is used up. Just like if you're trying to make cookies and you measure out your stuff and you keep making cookies until you run out of one thing. One thing's going to run out first. And for some of you, we did do a worksheet earlier where we talked about pizza, and you had to figure out which ingredient of your pizza was going to run out first. Any recipe that you go with, eventually you're going to run out of something, and that's going to keep you from making any more of that particular item. So stoichiometry allows us to do that. We're able to predict how many products we're going to be able to form. So we could take that cookie recipe and we could figure out, okay, here's my stuff. How many cookies am I going to be able to make if this is what I have on hand? So stoich is the study of relationship between those reactants and the products, and it's based on the law of conservation of mass, which says that matter is neither created or destroyed. So we can't have any more things in the products than we started out with in the reactants. They just rearrange them. So we're going to start out here with an example with breakfast specials. And in this breakfast special, we have 2 eggs. We have 3 pieces of bacon for each breakfast special. So the first thing we do is we always start out with a balanced equation. We have 2 eggs that are going to go into this. We have 3 pieces of bacon that goes into each breakfast special. And that's going to make 1 breakfast special. So our formula for that is going to be EG 2 BA 3. Now, they're telling us that we're starting out with 3 dozen eggs. 3 dozen eggs is, of course, 36 eggs. So we're going to start that out as our before amount. It says that we have a ton of bacon. So we've got so much bacon that we're not going to run out of bacon before we run out of eggs. That's just so much bacon. And so we're going to represent that by putting down excess. Instead of spelling the whole word out, we just use the letters XS. In the beginning, before we get started, we don't have any breakfast specials made. Now, the way we work these is we take this amount, whatever amount here we have, and eventually we're going to have amounts in both of these, but to start you out, we're just going to start out with one of these being excess, and then we know that we're going to run out of this one first. In another couple of days, we'll get into something called limiting reactant, and there you have to figure out which one you're going to run out of. All right. So we're going to take this and we're going to take it up into what is called the cloud. So when we take it up into the cloud, we're going to go through the coefficient. And when we go through the coefficient, we're going to divide to get that up into our cloud. Okay, so 36 divided by 2 is 18. Now, to come back down through here, we do the opposite of that. So we're going to multiply as we move down out of the cloud. And we multiply by whatever the coefficient is at the beginning here. So for here, we're still going to, if we came back down and multiplied, we'd multiply back out to 36. We're going to use up all 36 of those eggs. We're going to figure out how many pieces of bacon we're going to use up. So 3 times 18. 54. So we're going to use up 54 pieces of bacon. We're still going to have an excess amount of bacon left over, and we're not going to have any eggs left over. How many egg specials are we going to make? Well, 18 times 1 is 18. And so that means that we will have made 18 breakfast specials in the process of making this reaction happen. All right, so let's talk in terms of stoichiometry and what we're going to do in terms of that. So like I said, we always start out with a balanced equation. We have a known amount, and then we have unknown amounts, and we have to use our cloud to be able to figure that out. If we have mass that's given to us instead of moles, then we have to convert that mass into moles. And we learned how to do that back in chapter 10. We just use the mass off the periodic table, and we divide by that to get it into moles. Once we have it into moles, then we can put it into that BCA table that I just showed you a few minutes ago. BCA stands for before, change, after. And then if they want our answer to be in mass, then we have to take those moles out of that after section and convert that back into mass by multiplying by the molar mass off the periodic table. So here we go. This is an example of an actual chemistry kind of problem that we're going to be working with. And here we have our stoichiometric calculations that we're going to be doing. And they're asking us what is the number of moles of hydrogen produced when we have 0.04 moles of potassium used. So this one, they've already got it into moles. Remember, when we do these, only moles in the holes. So these are our holes down here. And the only thing that can be in these holes is moles. So this one, they gave us moles. We don't have to convert in from mass to moles. We just need to figure out where to put this. So they're telling us that we have 0.04 moles of potassium. So this is our potassium right here. We're starting out with 0.04 moles of that. This, since they didn't tell us how much, we're going to assume that we have an excess amount. And this is at the beginning or before our reaction has happened, so we don't have any products yet. Okay? So if we take this up into our cloud, remember when we go up into the cloud, we divide. So I'm going to have to draw my cloud up here because I didn't leave myself quite enough room. So 0.04 divided by 2 would be 0.02. And then they wanted to know how many moles of hydrogen would be produced. So I need to bring that back down here through my hydrogen. My coefficient here for hydrogen is 1. So anything times 1 is itself, so 0.02. So 0.02 moles is how many moles of hydrogen we would be using for this reaction. So 0.02 moles of hydrogen would be our answer. Moving on to our next question. This one is a combustion of a hydrocarbon. And with this one, they're telling us that we're starting out with C3H8. We're reacting that with oxygen, and we're producing carbon dioxide and water. They want to know how many moles of carbon dioxide we're producing. So we have to start out with our equation. I'm going to write our equation in here. So C3H8 plus O2. And that's going to yield CO2 plus H2O. All right, we have to balance our equation. Remember, if we have an odd number of carbon here, we're just going to start by balancing our carbon. So I have 3 here. I need to put a 3 here. Over here, I have 5 hydrogens. So I need to put 8 hydrogens. So I need to put a 4 here to get that up to the correct amount. Then I need to balance my oxygens. So 3 times 2 is 6 oxygens here, plus the 4 oxygens here is 10. 10 divided by 2 is 5. So I have my balanced equation now. I'm going to start filling in with what I know. They've told us here that we have 10 moles of C3H8, so I'm going to put that down here as my starting amount. They didn't tell us how much oxygen we have, so we're going to assume an excess amount. And this is before our reaction, so we don't have any one of these items present. So then we are going to try to figure out how much of our carbon dioxide is produced. So I need to take this value up into the cloud. So I'm going to take it up through the coefficient and into the cloud. And anytime I take it up, I divide. So my cloud value is going to be 10.0. Then I need to bring it down through here. Anytime we take it down, we're going to multiply. So that means that we're going to have 30 moles of CO2 produced. And that's what they wanted us to figure out here. If we want to go through and figure this out for the other items, because sometimes they will ask us to do that, this would be 10 times 4, which is 40. And over here with our oxygen, we're going to bring that down. That's going to mean that we need to have 50 moles of oxygen present. And we're going to have that because we have an excess amount. We're still going to have an excess amount left over. We don't know exactly what that amount is, but we know that it's an excess. And then over here with our carbon, or our C3H8, we're going to use up all 10 moles of that, so we won't have anything left. They will sometimes ask you, for example, if you start out with 10 moles of C3H8, how many moles of O2 will you need to produce? Sometimes they'll ask you questions like that as well, so be ready for those. All right, here's one more problem. We have sulfuric acid. It's formed when sulfur dioxide reacts with oxygen and water. So we have sulfur dioxide. It's reacting with oxygen and water. And it is forming sulfuric acid. Need to verify that our equation is balanced, which it doesn't appear to be right now because we have 5 oxygens over here, and over here we have 4. So remember the rule, even and odd, double the odds. So I'm going to double this. When I do that, I need to double this guy. So that then gives me 2 sulfurs that I need to balance. So I got to get those over here. All right, now let's add up our oxygens. Our sulfurs are balanced. Our hydrogens are balanced. We've got 4 oxygens here, 5, 6, 7, 8. So now we have this equation balanced. We can proceed. Write a balanced equation. If we start out with 12.5 moles of sulfur dioxide, how many moles of sulfuric acid can be produced? And then they want to know how much oxygen is needed. All right, so we're going to take this up into the cloud here. When I take this up into the cloud, we know we have excess this, and 0 of these. All right, back to the cloud. So I take this up through here. I'm going to divide by 2. That means my cloud amount is going to be 6.25. So then when I bring this down out of the cloud, I'm going to multiply. Okay. Here I'm going to use up all of this. I'm not going to have any left over. Here I'm going to need 6.25 moles of oxygen, and I'm still going to have an excess amount available. That should be excess. Sorry about that. Over here, I'm going to need to use up 12.5 of my water, but I'm still going to have an excess amount left over. And over here for my sulfuric acid, I'm going to produce 12.5 moles of sulfuric acid. So hopefully you've been able to follow that. Tomorrow we will be starting out with mass. We're going to have to convert those to moles and then do our Stoich here. And then after we're done with that, then we will move on and convert that mole back to mass. So tomorrow's mass to mass conversions. Hope to see you then.